And on page 180, right beside that shaded box, there's some space to the left, and I'd like you to add some additional notes. So those additional notes will look like this. So what we're going to look at in section 3.2 is what effect a negative has on a graph. So far we've looked at stuff affecting things by moving it left or right, or moving it up or down. Now, what would happen in function notation if you added a negative inside the function? So what we're going to say is, and again we're using the same kind of language that we've used so far, if the negative is inside the function. In other words, it is with the x. Do you see that that negative is with the x right now? If the negative is inside the function, if it's with the x, then there is a horizontal reflection over the y-axis. What's going to happen is your graph is going to get flipped over your y-axis. Algebraically, all your x values will get multiplied by a -1. So in the shaded box above, I'll just give you a couple of minutes to make sure you finish writing that down. But in the shaded box above, we're going to see what happens when that negative is with the x, and I push this question mark there. No, the graph didn't show up. No, I think I might have to hit this one. Sorry. And if you're not quite done writing it down, I will scroll down again, but I want to show you what happens if that negative is inside that graph. Let's say you had this parabola. What is going to happen is that this graph is going to get reflected horizontally, and horizontally is over the y-axis. That would end up being there. So if we estimated, if we would say it looks like the vertex of this parabola is at 3, 2, then the vertex on y equals f of -x will be -3, 2. The x coordinate, the x value, will get multiplied by a -1. So just like before, when things were inside of our function, it always moved things horizontally left and right before. Now, if a negative is inside the function, it's going to multiply the x coordinate by a negative. And that will cause your graph to get reflected over the y-axis, just like that picture. And then secondly, if the negative is outside of the function. And it could be written like this, or if I would multiply both sides by -1, you could see that, oh, the negative is with the y value. But mostly we write it as the left-hand side as negative f of x. So we can say if the negative is outside the function, I guess we could say if we moved it to the other side, technically, the negative is with the y, then there is a vertical reflection. And that reflection is over the x-axis. What happens algebraically then is all our y values are multiplied by a -1. So this is new. This is something we didn't see in our papers that we did at the beginning. Now we're adding a new transformation. It's a reflection. Sometimes a reflection will be horizontal. It'll flip it over the y-axis. And sometimes the reflection will be vertical, flipping it over the x-axis. So if we go to our example 1, everybody done? Okay. That's another thing that you'll have to do. Sometimes I'm going to get really excited about doing the next question, and I'll go too fast, and you will not be done writing your notes. And you will just have to say, Mr. JR, can you go back a second? And I'm totally fine with that, but just so you know, I will be like, oh, I want to get to this next question because it's a good one. Sometimes I'll go fast. Just remind me to slow down and go back. Not a problem. So here's the graph of g of x. Sketch the image graph after reflection in the y-axis. So first of all, we see reflection in the y-axis, and then again it says state, domain, and range of each function afterwards. With that reflection in the y-axis, you might go back to our notes and say, if I'm reflecting in my y-axis, is that a horizontal reflection or is that a vertical reflection? What does that look like in function notation? That is, since our function is g, over the y-axis is horizontal. Horizontal means that that negative would be inside the function. Inside the function means that it's going to affect the x values. Drawing it, all you do is take your points, and I'm going to actually label these 4 key points on here. We've got -3, 1, -1, -2, 3, -2, and 5, 2. If that negative is with the x, if it's inside, it's horizontal, it's affecting my x values. Visually, can you imagine taking this point right here and flipping it over the y? Can you see it would go right here to 3, 1. But algebraically, instead of having to count how many it is away and just like eyeballing it and getting exact, like, oh, did I reflect it far enough? Can you see that the only thing that's changed is the x-coordinate, which was -3, is multiplied by negative, now is +3. This x-coordinate at -1, if I multiplied it by a negative, it would become +1. -2 on the bottom still. This point at 3, -2, if I multiply the x coordinate by a -1, flipping it over the y-axis will send it over here to -3, -2. And this point at 5, 2, when you multiply the x coordinate by a negative, and can you visualize now taking this graph and flipping it over the y, that it would land on that blue graph? And so we have reflected the graph in the y-axis. But again, this language, you have to be prepared to say reflected in the y-axis, or horizontal reflection, or sometimes they'll say reflection over the line x equals 0, because vertical lines, your y-axis is over x equals 0. So you will get on an exam the same question, but they can change the language. So we have to think about all the different ways this same question could be asked. Now that we've got it, it says state the domain and range of each function. For this one, I'm only going to do interval notation. So interval notation starts with the lowest value, goes to the biggest value. For the red graph, the smallest x value is -3. The biggest x value is +5. Square brackets because they're both included. For your range are your y values. Smallest y value on the red graph, -2. Largest y value, +2. When we do our domain and range of our reflection, our domain, now our smallest x value is -5. Our largest x value is +3. Our smallest y value is still -2. And our largest y value is still +2. So a couple things I want you to notice. Okay? Notice the range didn't change. Why didn't the range change? Because we did something that only affected it horizontally. We had a horizontal reflection. That means x values are changing, but y values aren't. The same thing would happen to this graph if you moved it left and right. Can you see your y values would stay the same if you moved it left and right? So when things are affecting something horizontally, it's affecting the domain. The range stayed the same. Algebraically, we talked about the x values getting multiplied by -1. Can you see how that affected the domain? If you just look at one domain to the other, can you see that if I multiplied each of those values by -1, now I go from -5 to 3. Now the reason I point stuff like that out is because sometimes you're given a question and some of the context is taken away. You could have a question that says, here's the original domain and range. You just reflected it over the y-axis. What's your new domain and range? No graph is given. This one was easier to do domain and range because we had a graph that we could draw and then look at our graph to get the domain and range. But you could get a question that they just start with domain and range, tell you something has happened, and you have to say what the new domain and range is. Okay, questions to start on this one are 3 and 13.